Welcome to the ACETA Archive of Excellence. Today we're shooting episode 9 in the series, and it is Sunday, the 7th of May, and we're at the ACETA convention in Wangaratta, 2023. Today our inductee is a unique individual coming from a very interesting sector of our entertainment technology industry. It's interesting to note that we can talk about analog, and we talk about digital, and we talk about software, we talk about hardware and all sorts of things. But you know, really since the dawn of entertainment technology, the start of the chain and the finish of the chain has not really changed that much at all. And I'm talking about microphones at the start and speakers at the very end. Nothing's really changed much, a few modifications and whatnot. And Australia was once quite prominent in terms of producing transducers, as we'll call them. Some call them speakers, we'll call them transducers. And our candidate, our nominee today, is possibly the last transducer designer manufacturer that we have in Australia, to my knowledge. There may be others, but he is, for all intent and purpose, would appear to be the last of our transducer designers, which is unfortunate in my opinion, because it's such a vital part of the entertainment technology, and that's speakers. Anyway, without any further ado, would you please welcome Mr. Michail Barabasz from Lowrance Audio. So let's start at the beginning. So you arrived in Australia in 1951?
1951, yeah.
As a six-year-old?
6-year-old,
yeah.
Yes. I was born in 1945, and we were basically refugees. I was born in Germany, and we came here, and we had a choice of going to Brazil. Unfortunately, my dad picked us. It was either Brazil or Australia, and he picked Australia, thank God. And yeah, so I've lived there in Dandenong. We selected Dandenong because it was an industrial area, and they said there was work there. And there was work for my dad, but my first introduction to Australia was a summer's camp. We had to stay in a camp. We couldn't afford our fare, and we came here with absolutely nothing. We had only the clothes and nothing other than that. And fortunately, the Australian government looked after us and gave my dad a job. And yeah, and I did all my education here. I attended because I was 6, you've got to remember that I couldn't speak English. So I came here unable to speak English. We spoke broken Russian. My dad was Russian, Mum was Polish. And so we spoke multiple languages. And I was fortunate that I could pick up, because I started at such a young age, I could pick up English. And I learned English at school because we couldn't speak English at home.
Did you find was that difficult?
It was, because if I have a weakness, it's my public speaking. The thing is that if you're brought up with the English language, you know how to express yourself precisely and accurately. Sometimes I'll use the wrong word, which doesn't quite describe what I'm meaning, and that's because that's not my native language. I've had to acquire that, and I've had to learn those skills.
Right. Well, moving forward a bit then, let's talk about your passion for, I suspect, music initially, and then reproducing it, as in audio. And so was that part of your education?
It was, because my father had a great skill. He was very good at electronics, and although he couldn't get a job in the electronics world, he got a part-time job servicing radios and TVs. So our house, or the garage, it wasn't a house, it was in the garage, we would repair radios and TVs, and our weekends were spent like going to radio parts and buying electronic components. And my job was, and I'm only in a very young years, this is probably still in primary school, I would go with Dad and would buy resistors, and my job was to sort the resistors and put them into packets, and when a radio, he taught me, I could read a circuit diagram way before I went to tertiary school. And so I had those sort of skills, and my dad sort of taught me how to diagnose and solve problems. He goes, what do you think's wrong with this radio? So I have to get the valves out, put them in a valve tester, test them, because we had those sort of things. So I became very familiar with electronics. I could build gear, and because we were poor, we also built we couldn't afford to buy equipment. So in the course of time, we had to build our own oscilloscope, our own signal generators, our own measuring equipment to do the servicing. And therefore, I learned the skill of being able to make things. And I think that set me up for life. And that's why my dad said I had to do engineering. So,
okay, well, so in summary then, you were really initially taught by your father, and then you just had a natural aptitude.
Yes, but...
And a love of music?
Oh, absolutely, because the magazines came about, and our magazines were all electronic magazines. So we would get electronic TV and hobby magazines, and of course, I'm interested in the reproduction of music, because we could build our own hi-fi set, and so we built our own amplifiers, and I think my first hi-fi system was a Decca RAM cartridge, and I won't name the brand of the British loudspeaker, which my dad purchased. We did a lot of research, and we built the Briggs, had a book on Briggs enclosures. We built that, and we were very proud of that hi-fi system. And I always had the passion about music and music reproduction. In fact, I was trying to build a tape recorder, and what I got for my birthday, what I wanted at a very young age, and I'm talking probably 14 years, I said, can I have some Colorado recording heads, because I want to build my own tape recorder.
And this is around the age of 14 you were doing this?
Yeah. Right. And I thought, I want to build that, because we can't afford one, but I can build one. But all I need is a recording head, and I'll get that done. And fortunately, we should talk about my education, because I went and did electrical engineering, and it was great, because when I did electrical engineering, all of a sudden I had to do some machining, which I really hated, because I was into electronics. But I go, wow, now I can machine some components, because when I had my reel-to-reel tape recorder, I'd used a motor out of a turntable, and I put a rubber roller on it to do that, and I had a take-up rubber band going to the take-up spool, but I'm going, it changed the tension, so I had to have a slipping clutch on that. So I go, oh, there's a lathe there, I can put that and have a slipping clutch, so that...
You learnt on the job.
I did, I learned on the job, and mainly because we're repairing things. I could see how things were made, and it gave you an insight into a good design as well.
And so this, therefore, we fast forward, I guess, a few years, but I became aware of you in my days at Strauss Sound Systems, because you were at Plessy Roller. So that was your first professional job, wasn't it, Plessy Roller?
My first job was Plessy Pacific. It was an electronic, I was a technician at Plessy Pacific. Made the key sets for the TAB, which talked to the computer. So all the bits were placed on and entered through a keyboard, which went to a central computer. It was a big project, and Plessey Pacific had to build these. My job was to test all the PCB boards and fault find those. And they also.
What year was this, by the way, Mike? 60s?
Yeah, it was 60s. I was, at that stage, I'd completed electrical engineering diploma course, and I was, didn't like electrical engineering. I found it rather simple. I wanted to do electronics, which was more complicated, and I then did the electronic course. So I was doing that part-time while I had this technician job. And unfortunately, that job finished. And we were going, well, don't come Monday, because we'd completed that job. And because I was an engineer and I was doing the electronic course, the people from the materials guy must have been the top guy, and I found education really easy. I was always top of the class, always. In fact, I didn't have many friends because I was a bit of a nerd. Yeah, so Dr. Levy said, you're really good at materials. We could use you at Plessey Roller. Like, do you want to work at the wire plant? And I go, no. We've got a magnet division. Do you want to work at the magnet division? No. Magnet division? No. Anyway, they went and thought about it, and they said, came back to me and they said, we've got an R&D division. Okay, that sounds exciting. You know, I can be creative, I can do stuff. Let's do that. So I got my first job as an R&D engineer.
At Plessey Roller?
Yes.
In Richmond?
In Richmond,
yeah.
Yes. And Plessey Roller made, they had a press shop, they had a wire plant, a magnet division, and at the Richmond plant, they assembled loudspeakers, but they also made tape recorders, they made wound components, TV components, encapsulated components, where we could encapsulate transformers for defence, where they had to be waterproof, solenoid, a variety of things. And there was a lot of manufacturing going on. And Plessey was a huge organisation.
And we at Strauss Sound Systems in the mid to late 60s, we used to buy lots of your 12-inch drivers for our PA systems, probably designed by you.
Billy Woodman, who formed ATC, was the engineer before me. And he left and went back to the UK, and they tried to find a speaker engineer, and speaker engineers are really hard to find because who's been trained in designing loudspeakers? No one. So I think they had tried about 5 engineers and they lasted about 6 months. You've got to remember, Plessey were making 1-inch speakers, 2-inch speakers, up to 12-inch speakers. They were making ovals, 5x3, 6x4, 7x5, 8x4, 10x3 at that stage. And the main business for TV and radio, the biggest one was a 12-inch, and the most icon speaker was the 12UX loudspeaker. And that had been designed. So what happened was that when they couldn't find a suitable engineer, I was given the ultimatum: you either become speaker engineer or you don't have a job on Monday.
What year was this around about? What period of time?
1970s.
Yeah. And just for the information of the viewers, the manufacturing of speakers was massive in Australia. We produced all our own stuff, and a lot of this was due to the tariff protection appended to imports, which was something like 49% duty. So the Australian industry was really, really big.
Certainly, you're absolutely right.
But it also died very quickly when Gough Whitlam removed the tariff things in the more the mid 70s. So we could perhaps move on there and just sort of talk about Plessey Roller closing in the mid 70s.
That's right. But basically, I designed some loudspeakers there, CAO, CAOX, the 10-inch and dome tweeter, and the C12P, which became the biggest selling loudspeaker for Plessey after the car audio. Their main business was car audio because there were 400 cars made every day, and there were 2 speakers. So Ford wanted 800 speakers, and GMH wanted 800 speakers. So it was big.
This is per day?
Per day. And my job was to write the specifications for and design the new products. Now, when the tariffs came in, we had 40% protection, and that disappeared. And therefore, we lost the car market. And at the end of the day, we were making car speakers with only the variable overheads. Now, Plessey had quality control. They had the best costing. We had computer printouts for every customer, the reject rate for every customer, and I had access to that. And at that stage, I was also advised to do a management course. So I went and did a management course because they said, well, you're not going to get a job in loudspeakers. You should move into management. So I did part of the management course, and finally, Plessey closed. They wound up, and they said, what are you going to do? And I said, well, I've spent too much time designing, and my expertise now had become loudspeaker design. And Plessey also instigated research into paper pulp. And that was a significant improvement in speaker technology because nobody's interested in working with paper. And I'm an electronics guy, and all of a sudden I've got to learn how to deal with paper, how to process paper, how to make cones. And what I didn't understand is what influence does cone shape have? What influence does different paper materials? And I had to learn how to blend and make the mix of paper to improve the sonic quality because we competed on performance. We were competing with Magnavox and MSP. And I had to make the best sounding loudspeakers.
So you established Lowrance Audio. You bought the plant and equipment from Plessey Roller?
Yes, I did.
And set up in 1976?
Yes, that's right. Fortunately, when I told management that I wanted to continue in loudspeakers, and they said, well, how are you going to do that? And I said, well, hopefully I can acquire some bits and pieces, because I had all the figures of what was viable. And the C12P that I designed to replace, we had the Poseidon nickel crisis, and nickel became too expensive, and the icon in the industry, the 12U50 loudspeaker, became too expensive. And the sales fell, so I had to come up with a cheaper alternative, and I came up with the C12P. And by good fortune, it was a replacement for a 12P loudspeaker, and that wasn't a good seller. And I knew that the 12U cone was the best cone that Plessey made. I said, why don't I put that into the... But it didn't fit the housing, so we thickened up the housing, stretched it a bit more, because I had a tool room, and I forced it to work. It became the 3rd best money earner for C12, for Plessey Roller. And they couldn't make enough of them, to be honest. And I could see, oh boy, there's money to be made if I just make that driver and take my 10-inch that I designed, which was a good seller, and I put all that together, I could have a viable business. So I said, look, these are the things that I would like to have.
So the technological progression into Lowrance, started with Plessey, your work at Plessey Roller, and then developed further when you set up Lowrance.
That's right, because I learned, because everything at Plessey had to be very disciplined, and I had to write process specs. So when you have to write process specs so when I design a new loudspeaker, it's not just designing the loudspeaker, you have to tell the paint department what paint to use, what pop pressure, how to mix the paint, what the viscosity of the paint has to be, how long it's got to go in the oven to be cured, and all that. In the paper pulp, you've got to say what the blend of paper is, how long does it go in the refiner, and you write it for production. Because the funny thing is, I designed all these loudspeakers at Plessey Roller, never ever made one myself. They gave me an assistant. I had an anechoic chamber, a listening room, and an assistant. So I had to go and say, I would like this cone here with that voice coil, with this magnet assembly. You put that, and my assistant would go in the factory. I wasn't allowed to go in the factory and interfere with production. So I designed the product and tested it. But I acquired those skills because everything was there. So I graphed every loudspeaker, and I'm methodical in that I would actually put every speaker I'd graph, I'd actually take it home and write down. With this shape, it has this kind of characteristics, it has this bandwidth. If it's got that, if it's flat, if it's like this, it sounds different. And in the end, when you work with that sort of product, you get an understanding of how cones behave, but it was still trial and error. So the speakers that I designed were guesswork. They really were. There were no tools to help you. In other words, how deep should the cone be? Should it have cone corrugation? Should it be flat? Should it be curved? There's nothing on that. There's so many books about audio, about hi-fi, and they talk about, yes, we know there's a crossover, we know there's a box. But when it comes to the actual transducer, there was nothing.
So 1976, you've established Lowrance in Dandenong.
Yep.
How many products did you make in terms of, when you started out, how many models were there, roughly?
We started, it was what can I say? It was a very difficult, I didn't understand how difficult it would be to run a business, because I used all my severance pay to buy the tools and bits and pieces, but I couldn't buy the measuring equipment because they moved into retail selling, Foster. I went to Japan and we selected Foster. The government told us that we shouldn't be making loudspeakers, we should be importing. So I only finished up with the tooling, and that took up all my severance pay. So I got nothing when I left Plessey, although I'd worked there and designed their best products. I was not rewarded monetary-wise for that. I got a truckload of parts and bits and pieces, but that's all I had. No money. And I go, what am I going to do? So I started my dad's factory, garage. He didn't have a factory, it was a garage.
So Lowrance was initially your father's garage, right?
Yes. And I had to send my poor wife out to work because I had no income. We had no customers. So Hazel had to go out and work at Drake Overload, getting part-time work to put food on the table. I looked after my little girl. I had a little daughter. She was 3, so I had to do that in my dad's garage, and I set up it there.
It's worth mentioning at this particular point in time, we don't often do this, but Lowrance, to us and the outside, it's Mike and Hazel. They're the team, and realistically, in terms of reputation, a very successful team. So we should acknowledge Hazel too. So a couple of years have gone by, and the interesting thing you said, and I don't know whether anybody's picked up here, and I'm a speaker guy, I design systems, I've done a bit of transducer design, but I don't know many, if any, transducer manufacturers in the world who make their own cones. That's another art. Making, paper, or textile cones. And Mike's always done that. At Plessey Roller and at Lowrance, they make their own cones. And I actually think it's probably worth looking at that for posterity, of the importance of that, of the skill, because Lowrance have produced some world-leading innovations that are used in just about every guitar amplifier in the world. It's just come from Dandenong in Victoria. So would you like to just tell us a little bit about cones and what you've done?
Yes, basically the heart of the loudspeaker is the cone. Most people can copy the hardware. It's not that difficult to pull a speaker apart, measure the bits of the physical size of the magnet, and duplicate that. So what is the difference between speaker A and speaker? The heart of it is basically the loudspeaker cone. It's the voicing characteristic. And when we're going to get, if we want a guitar cone and basically the Celestian sound, the things that influence the voicing characteristic are the shape and the material. And there was a relationship between Roller UK, Roller Australia, and Jensen Roller in America. It was way before my time, but I believe there was some sort of connection because the 12U cone, which was in the 12UX, had a 28-inch radius, and that became the voicing characteristic for a British sound, for a felted cone. The Americans were using a seam cone, which is a different kind of cone. It's not as crisp. So a seam cone is made from basically very soft paper pulp. My expertise is making what we call a felted cone, where you actually buy paper pulp from a paper mill and then refine that paper and then separate all the fibers and using vacuum, suck it down onto a tool die, and then it goes into a press. It gets water treatment by lacquering. Oh, there's chemical additives and other things. I don't know how detailed you want to go into the paper making, but there's an art form and it's lost.
It is lost, isn't it?
It's completely lost. It's lost almost worldwide because what's happened is that people go, make cones. No, there's no money in making cones. It's the cheapest component of that. And who wants to go and make paper pulp? If you see me, I don't look like this at work. I work with black dyed paper pulp, and it's everywhere, and it's on the floor, and you know. It's a dirty process, but it is the heart of the speaker, and you have the passion to understand it. And there was nothing to help me with the paper. CSIRO helped us said, look, use eucalypt because it's local and it's something you can control, and you need a refiner to refine it to get the, so when we refine the paper, we actually change its Young's modulus, its damping and whatever, and therefore you've got control of that. So they said, you need that. And my job was to implement that back at Plessy Roller. So when I moved into my own business, I said, I've got to continue with that technology because it gave us an edge. We had a sonic signature, which was everybody accepted. The clarity, it went loud, it performed well, and it was quite accepted. And lo and behold, I think 13 years later, I think there was a guy, Harrison, in the UK, patented the blend of. So originally at Plessy, we only had eucalypt. When I started making speakers at Lawrence, what happened was all the speakers at Plessy were very low power speakers, and all of a sudden my customers are saying, oh, we want more and more and more power. And what I found was that the eucalypt so eucalypt is hardwood, which is broadleaf tree, and most cones are made from softwoods, which are needle type trees. They're easy to work with because the fibers, and they don't tear because the fiber length is long. So what happened when the power increased in these guitar, and people were starting to push more bass into my speakers, the cone started to crack around the outside edge. And because of my material expertise, I go, how do I stop this from cracking and make this eucalypt? I don't want to really lose the sonic signature of that, but I need to add something to that to make it work. And I found that hemp was the best substitute, and because I couldn't tear it. I couldn't tear a sheet of paper. I go, wow, this is unbelievable. They make clothes out of it, but it's not stiff. It's not a great cone material, but a great additive. So I added this hemp, and the Americans call it the hemp cone. It became a new, all of a sudden it gets reinvented, and it's a new cone, hemp cone. Wow, you know. And I go, no, it's not a hemp cone, it's actually eucalypt. And Harrison patented a blend of 40% hemp and 60% eucalypt, which is basically what I did 13 years ago.
It's interesting that Mike's talking about that, because when you've been around as long as I have, what you've seen a change in the way things like timbre, T-I-M-B-R-E, tone, this sort of stuff. And today, a lot of production is done with the eyes and not the ears. You know, you're looking at screens. You can go into a recording studio today and they're listening, watching the screen. And so that's one of the reasons there's a lot of issues about quality, and perhaps a lot of reasons why people love the music of the 60s and 70s, because it was all about tone, you know, and the engagement, and you know, and we're not so much concerned about it anymore. Mike's just saying that, you know, no one's bothering much with cones anymore. And that's
because you have to have passion. There's a passion. I have a passion to deliver a great product. I'm not interested in making a bad product. It has to withstand and survive competition. And therefore I instigated research into, because I said, like, there's nothing out there to help me. And because I was a top student at RMIT, I met Mr. Beanland, who was, I think, counsellor for RMIT, and he said, what are you doing in loudspeakers? And I go, like, there's nothing to help me, mate. And he said, like, we can help you. We'll get a student. It took 3 years to find a numerical student who could actually model and produce. So I knew it could be done. I knew that a physical model could be, with a computer and the right bit of software, can predict the sound pressure level. But there wasn't anything out there, and nothing that I could afford. So he found that this David Featherston, and he started on a PhD project. And we did a lot of research, and he wrote the software, did the matrix. So the structure's got a stiffness matrix, and then you work out, you break the cone up into little circular things, and then you integrate from each element what the sound, it predicts the sound pressure level. It did a lot of things. It told us all the eigen modes in the structure. It told us all about the stress levels in the material. And all of a sudden, I could actually, on a computer, change the shape and see what effect it had. Previous to that, it was experimental. You tried it, but every time you tried it, it cost you $10,000 worth of tooling to retool a cone, just to try something, and most times you went backwards. So this was a great step forward, because all of a sudden, all the things that it's about understanding the intricacies. How do you make the best driver? How do you control the eigen modes? How do you control the stress? And I knew the stress in the cone would cause distortion, but I didn't know that. But these models confirm what I said. Yeah, that peak in the distortion, I think it's due to a breakup mode or stress in the thing. That all of a sudden it became clear. With the numerical modelling, we could actually correlate what we were measuring and what we were hearing back to a model, and said, that's due to this. And and that was the eye-opener to me, because all of a sudden we had a tool to help me in my quest for making a great product. We didn't have that prior to that.
So your life really has been a constantly caught up in researching and developing. And so just that progression, it's any wonder you've ended up with a hell of a product. And one would only wish that more Australians would support, you know, local geniuses like this. And there are others in other fields, but they all struggle. And and we just don't want to lose this capability. It's got to be perpetuated, and I hope this episode is viewed widely. But before we wind up, Lowrance today.
We make our main business, in the early days, it was 50% hi-fi and 50% PA speakers, but the hi-fi industry moved away and became high volume, and the price was quite low. So I had to specialise in making more pro sound devices. So my skill is in designing pro sound loudspeakers, and we make a range of speakers. Smallest one we make now is 8, and we make up to 18-inch loudspeakers.
From 8 to 18?
Yes, and basically we've retooled all that. We bought CNC machines. I've got 2 CNC lathes, I've got a CNC mill, and I've had to increase my skill level, both in manufacturing, because we're a relatively small, unique business.
You are.
And I knew we had to make our own cones, and I knew what we had to produce, and it had to be done to the highest tolerances to be competitive. So we invested a lot of money into CNC machinery and measuring equipment. And measuring equipment has completely changed. And without measuring equipment and the right tools, you can't move forward. And it's all about understanding the device, and every device has got weaknesses. And what you have to do is be able to identify the weaknesses and fix those weaknesses in the speaker. And we now have a lot of tools. And being an engineer, I model a lot of things. So I model all my products at home on a computer, and it's a full-time job. We're a small business, so I have to do everything. I have to do the marketing, I have to do the building, I have to do the sales, and you have to be multi-skilled. And it's really beyond the capabilities of one person. And this is where it's so important to network with people and know what is required out there.
Yeah. Maybe you need a distributor.
We need a distributor. Well, you know.
There's plenty of them here.
That's what you need, basically, because you can go in different directions, and we've got some awards. We got an award in 1990 for Services to the Industry Award for helping people. And I designed products for AER, business in Asia, and I was offered a position to go and move into Asia and design speakers in Asia. My wife didn't want to go to Asia, so unfortunately, fortunately, we stayed in Australia, and I've worked with Australian customers, and I've been supported by people. Unfortunately, we've sort of stayed within Victoria. We haven't really gone and attacked the whole market, but I make what people want, and I refine what people need, and that's my skill set.
We're awfully glad you did stay in Australia, Michael. And so we could, as we start to sum up, we could say that you're vertically integrated, not in the sales side of it, but in production, because given you make your own cones and you pretty much make everything, don't you?
We make our own cones. We've got CNC machines, so we machine all the components. I design them. I use the best software that you can have, so we can actually computer simulate everything. We can design the enclosures. So I'm an expert on many fronts. In crossover designs, I use software like Leap and CASD, and I design those at home, but at the factory we basically manufacture. So we make our own cones, our own spiders, we build and we test, and I do my own data sheet, and we finally actually got a web page and all the products on the lowrance.com.au website. But we're flexible. We basically, the product range comes from customers. So we're looking for a business. And unfortunately, the manufacturing industry in Australia has declined. And it's been rather sad from that point of view.
It is rather sad, but if ACETA's got anything to do with it as an industry peak body, we do have to be more self-sufficient in this country. I think passage of time will prove that to be correct. We do need to value add and we do need to make things. And I think anybody here and who's viewing this episode, when you're thinking speakers, think Lowrance, check it out. Google, you know, have a look, because it's a wonderful product and something we ought to be really proud of. So we'll wrap it up now and wish you luck going forward, Hazel and yourself, and would you please show your appreciation